of pyramids. Remember, a pyramid is a completely different shape than a prism. The differences are pyramids only have one base. So I'm guessing in the formula it's not going to say plus 2b, right? It's just going to say plus b. Also, the lateral faces of a prism, of a pyramid are triangles. They are not rectangles anymore. So that's a big difference in a pyramid versus a prism. I'm not concerned that you write down all these definitions. I'm just concerned that you understand what they mean. So I'm not giving you time to write down all these words. I just want you to watch and listen, okay? A regular pyramid, of course, is a pyramid that has a base that is a regular polygon. I think almost all of our pyramids are going to be regular. So every time, even if we don't tell you, you can assume the base is regular. So if the base is a rectangle, it's really a square. If the base is an octagon, it's a regular octagon. All sides are congruent. So even if we don't tell you, you're allowed to assume. The lateral faces are triangles. They're not only triangles, but they're isosceles triangles. The reason they're isosceles is because our bases are most of the time going to be regular. So they're going to be not just triangles, but isosceles triangles. This is a really important slide. The important part of this slide is knowing the relationship between the height, the lateral edge, and the slant height. Okay, so I try to color code them. I don't know if you can tell. The height is easy. The height is the altitude of the pyramid. The height is a line that is piercing through your pyramid, right through the middle, right through the exact center of the base. The lateral edge is this edge right here. Can you see that? The slant height, the variable for slant height is a cursive L. Cursive L, like that. It's like a leaning over L for leaning. Slant height's leaning. The slant height is this value right here. It is the height of that isosceles triangle. So this is an edge. This is the slant height. Edge, slant height. Height, right through the middle. Slant height. See how the slant height is slanted? This height is straight up and down. The slant height is slanted. I bet I could use better things than a purple pen and a clear, but this is what we have, so that's what we're going to do. Okay, so the slant height, the height, and the apothem of the base form a right triangle. Guess what that means? You're going to be using Pythagorean theorem. Maybe you'll use 30, 60, 90, but most of the time you'll be using Pythagorean theorem. So what is that triangle made up of? It's made up of the height, the slant height, and the apothem of the base. Put that in your notes, that triangle right there. The height, the slant height, and the apothem of the base makes a right triangle, shooting through your pyramid. Trig will be rare, if at all. I can't remember. I don't think there's as much trig because there's so much more going on in a 3D solid. I don't think we're going to make you do trig inside of it. Yay! Don't quote me on that, even though this is recorded. Okay. You know what I would rather do first than this? I'm just going to give all the formulas to you first. I'm going to go out of order, and then we'll try it. I want you to write all of these formulas down, even though they are on your formula chart. I would like you to have them in your notes as well. Let's talk about each of these. LA, PL divided by 2. So P is the perimeter, so it's the perimeter times the slant height divided by 2. We're dividing by 2, it's kind of a long story, but we're dividing by 2 because a pyramid is not going to have the same amount of surface area as a prism. The prism has more to cover than the pyramid because the pyramid comes to a point. So perimeter times slant height divided by 2. The surface area is the lateral surface area plus the base. It's the lateral surface area, which you already found, plus 1b, just the base, the area of the base. And then volume is base times height divided by 3. Did you know that if a prism and a pyramid have the same base, 3 pyramids fit into the prism? Did you know 3 of them? To me, it only looks like, I don't know, maybe 1.5 fit in there. 3 of them fit in there. Do I need to show you? Should I show you? We have a pyramid and we have a prism. They have the same height and they have the same base. So that's why this is going to work, because they have to have the same height and the same base for this to work. So I'm going to fill this up and we're going to see how many times it takes. I'm just using my water bottle to fill this up and dump it into, okay, whoa. Okay. Steady hands. Woo! So that's 1. Let's focus in there. That is 1 pyramid poured into my prism. See how that's only 1/3? You would think it's more, but it's really not. It takes 3 pyramids to fill a prism. This is number 2. I'm not quite filling it to the very top because I'm doing this on a laptop and I don't want to ruin the laptop. You see how far up it is? This is 2. And as you can imagine, 1 more is going to fit. Going to fit. Gonna is not a word. Okay. Last one. Do I have enough water in my water bottle? Looks like I do. Whoa. I went over there. Splash. So anyways, you get the idea. I was a little conservative, but look, now it is full, like almost to the brim. It's water. You really can't tell. It's clear. I need food coloring. But anyways, it's full to the top. See how it's like shaking? So anyways, moral of the story, that's why it's divided by 3, because 3 pyramids fit into a prism when they have the same height and the same base. All right, let's get working on some examples. Oh, okay, good question. What is the perimeter on a pyramid? Well, capital P stands for perimeter of the base. It always stands for perimeter of the base. Capital P is not perimeter of the 3D figure. It's the perimeter of the base. So I can't answer that question because it's going to depend on what your base is. If your base is a hexagon, it's the perimeter of the hexagon. If your base is a triangle, it's the perimeter of the triangle. Johan says, isn't it 2B for SA? Well, I already went over that. They only have 1 base. I'm going to make an executive decision. We're going to jump right into the difficult problem because we don't have time for both. So we're just going to do the toughest one, and that'll make your homework seem easier. Okay, so we're going to do baby steps. We're going to find each of the pieces, and then we'll find the values, the LA, SA, and V. Okay, P, what is capital P in this example? Everyone type it. This is a hexagonal pyramid. Good, it's 4 times 6. There are 6 sides, and each side is 4. So capital P is 24. What is the slant height? Here's where we get into Pythagorean theorem. 6 is the altitude. 6 is the height. It is not the slant height. So this problem is going to get really difficult really fast, okay? I'm going to redraw this triangle right here. Boom, boom, boom. I'm going to redraw that triangle right here. This is 6. This is not 4. I told you this triangle was made up of the height, the slant height, and the apothem of the base. This is the apothem of the base. So in a hexagon, if the sides are 4, what's the apothem of the base? 2√3. It's 2√3. No, it's not. The apothem. Yep, 2√3. Yeah. If you need help with that, you need to draw the hexagon facing you. And draw this right here. This is your apothem. This is 4, so this is 2, 2√3, and 4, but we don't care about that. The apothem is 2 root 3. It's 30, 60, 90. Okay, we still need the slant height, so we have to do Pythagorean theorem. And you were so glad that we didn't have to do trig, but you didn't know you were going to have to be doing Pythagorean theorem with radicals. All right, a squared plus b squared equals c squared. Yep, we are going there. 36 plus, what's 2 root 3 squared? We have to know how to do this by now. 2 squared is 4, and the square root of 3 squared is 3. 4 times 3. So we have 48 equals slant height squared. How do you undo squaring something? You square root it. So it's 48. And what does that reduce to? 48 is 16 times 3. 16 is a perfect square. It's 4. So the slant height is 4 root 3. I'm telling you guys, I do the toughest ones in the notes. That way your homework seems easy. I know this is tough, but we've gotten through the brunt of it. Okay, LA. Okay, this is a new formula. PL divided by 2. This is going to be a breeze now that we know what P and L are. So it is 24 times 4 divided by 2. Are we okay with that? I didn't put the root 3 in my calculator because we don't want decimals. So what is the LA of this pyramid? Good. Okay. Capital B. Oh no, we have to find the area of that hexagon. But we already found the apothem. Let's go to the side and do some work. The area is apothem times, okay, perimeter. We already found that. It's 24. That's old news. The area of a hexagon is apothem times perimeter divided by 2. That's not so bad. It's just 24 root 3. Whew! The surface area is LA plus B. So it's just 48 root 3 plus 24 root 3. Those are like terms, so we're allowed to add them. 48 plus 24. The surface area is 72 root 3. Whew! We can do this. What's the height? Oh my goodness, that was handed to us on a silver platter. The height is 6. What's the volume? It's not base times height because I did the whole water example and spent time doing that. It's base times height divided by 3 because 3 pyramids fit into a prism. So it is base times height divided by 3. So are y'all getting 48 root 3? It's the same as the LA. We're going to have an assessment later. It's going to be next 6 weeks, but you're going to have to find the surface area and volume of composite solids. That means more than one solid combined. So we are sprinkling these out throughout the lessons. That way when you get to the assessment, you're not like, oh, I've never seen that before. So anyways, this is really important. We're going to find the surface area and volume of this figure. So first we need to figure out a strategy. What is this figure made up of? This is a rectangular prism and a rectangular pyramid. Although they're squares because it's 24 by 24, but you know a square is a rectangle. So to find the surface area, there are multiple ways to approach this, so don't get mad at me if I'm not doing it the same way you are. To find the surface area, you can just find the area of each face and add them all together. Or you can find like the LA plus 1B plus the LA. Let me tell you what I mean by that. So I'm going to find the LA of the prism plus a base of the prism plus the LA of the pyramid. Whoa, that might have gone on over your head, but I'm going to talk about it real quick. This still has water in it. Oh no. Okay. If I want the surface area of this figure, I want only what's on the surface. I only want what I can touch. I cannot touch the bottom of this. Can't touch it when it's here. So that's why I'm finding only the LA of this. And I can't touch the top of this. So I can't touch the bottom of the pyramid or the top of the prism. So that's why I'm going to find the LA of the prism, but I can touch the bottom. So that's why I only need one of the bases, plus B. Then I can only touch the LA of the pyramid. I can't touch the bottom, so I don't want the surface area of the pyramid. I hope this makes sense. So let's start to find them. The LA of the prism. So that is P times H. The perimeter of the prism, 24 times 4. 96. And the height of the prism is 15. Okay, how do you find capital B for the prism? Capital B would be like side squared, right? Because it's a square. So 24 times 24, or 24 squared, 576. And then the lateral surface area of a pyramid. Remember, you don't need to memorize any of these formulas. You always get a formula chart. P L divided by 2. The problem is that we don't have the slant height. The slant height is not 9. So let's find the slant height really quick. In this triangle, we have 9, we have 12, and thank the Lord that that's a Pythagorean triple. 15, right? Oh my goodness, so much easier than that other one. 9, 12, 15. Oh, so, P is the same as the other one. It's still 96. L is the slant height, 15, divided by 2. Now that I have all of those values written down, notice I'm not just plugging this into my calculator. I'm writing it down first because it's so easy to make a mistake. Now that I have it all written down, I'm going to go straight to my calculator, and the calculator is going to do the rest of the work. Okay. 96 times 15, hope you're doing this with me, plus 576, plus 96 times 15, divided by 2. Okay, so I'm getting 2,736 feet squared. Now we're going to do, oh, it just said find the surface area. It didn't say volume. Cool. Whew, thank goodness. Volume would have been easier, actually. That's why we did surface area, because that was a tougher one strategy-wise. All right, we are done with this lesson. Check out the homework help if you're having trouble with your homework. Have a great weekend.